Hello everyone, it's good to have you back on Step by Step Academy. In today's lesson, we will learn how to change the subject of a formula from a present variable to another variable present in the formula. As you progress in your study of mathematics and other science subjects, you will come across several formulas with different subjects. Sometimes it may be necessary to change the subject of a formula from a particular variable to another variable present in the formula, and that's what we'll be learning how to do today. However, before I go ahead to explain the concept behind changing the subject of any formula, let's look at the diagram before us. In the diagram before us, we have a list of plane shapes and solid shapes and some formulas. Our objective is to match the corresponding formulas, the formulas with the corresponding shapes. I'm sure you're familiar with all these formulas, most of these formulas, if not all. The first formula is the formula for the area of a triangle, half base times height. So these will match with the triangle. The second formula is the formula for the area of a circle. So this will match with the circle. The third formula is the formula for the volume of a cube. The fourth is the formula for the area of a rectangle. The fifth is the formula for the volume of a cylinder. And lastly, formula for the area of a square. Now, apart from these formulas, are there other formulas you can think of and what they are used for? Of course, like I said earlier, there are several formulas. For instance, we have I is equal to PRT over 100. That's the formula for calculating simple interest. And for those of you doing physics, I'm sure you're familiar with the second formula, V is equal to U plus AT. That's the first equation of motion. And T is equal to 2 pi square root of L over G. That's the formula for calculating the period of oscillation of a pendulum bulb. Now let's look at the concept behind changing the subject. What do we mean by the subject of a formula, and how can we change the subject of any formula? The subject of any formula is the letter or the variable that is standing alone, either on the left or on the right hand side of the formula. So in this formula, V equals to U plus AT. The present subject is V because V is standing alone on the left hand side of the formula. Now let's look at the concept behind changing the subject of any formula. I'd like you to pay attention here because I'm confident that if you understand these 7 concepts that I'm about to explain, you will not have any trouble changing the subject of any formula, no matter the complexity of the formula. For concept number 1, we have x is equal to y plus z. Presently, x is the subject, and we have to change the subject to z. Usually, whenever you are changing the subject of any formula, you will always do the opposite operation, the opposite or the inverse operation of the operation you have in the formula. For instance, in this number 1, the arithmetic operation involved here is addition. Therefore, to change the subject, I'm going to do subtraction. Opposite of addition is subtraction. And to achieve that, I can simply say minus y from both sides. So, x minus y is equal to y plus z minus y. If I minus y from the right hand side, I'll be left with z. Remember, we said your subject can either be on the left or on the right hand side. So in this case, my subject z will be equal to x minus y because z is now standing alone on the right. Therefore, the subject z is equal to x minus y. Now for number 2, x is equal to y minus z. Now in this case, my subject is being subtracted from y. So in order for me to change this, because my subject here is having a negative sign, I recommend that whenever your subject is having a negative sign, preferably always move the subject to the other side. Move the subject to the other side so that it can become positive. So what I would do here is to move minus z to the left hand side, and that will become plus. So I'm going to have x plus z is equal to y. Now look at, my objective is to make z stand alone. Now this z now is added to x. So what I can do now is to move x to the other side. So if we move x to the other side, z will now be equal to y minus x. So we have z is equal to y minus x. So that's how we change the subject from x to z. Now look at the third concept. X is equal to a times y. Now here, this talks about a situation where your subject is multiplying another variable. So the subject here, our intended subject here is y, and the y is multiplied to a. So what is the inverse operation of multiplication? Very good. The inverse operation of multiplication is division. So that means here, to make y stand alone on the right here, I will have to divide both sides by a. So divide both sides of the equation by a. So a will cancel a here. What will be left is y is equal to x over a. So y equal to x over a. Y is equal to x over a. Concept number 4. Concept number 4 talks about a situation where my subject is involved in a fraction. Whenever your subject is involved in a fraction such that you have a single fraction on the left and a single fraction on the right, what you do is you cross multiply. So here we'll cross multiply. So if I cross multiply, z will go to the left to multiply x, and that will give us xz, and y will go to the right to multiply a, that will give us ay. Now don't forget, our target is letter x, and you can see the letter x is multiplying another variable z, or another letter z. What is the inverse operation of multiplication again? Very good, division. So we divide both sides by the z. We divide both sides by z. Z will cancel z. So we have x is equal to ay all over z. Ay over z. Concept number 5. Concept number 5 talks about a situation where your subject is having a root. Now the inverse operation of root is power. The inverse operation of root is power. Please don't forget that. And the inverse operation of power is root. Therefore, in this case, to remove this cube root, I have to raise both sides to the corresponding power, which is power of 3. So to remove the cube root on the x, I will have to raise both sides to the power of 3. Raise this to the power of 3. So these 3 here will cancel the cube root. Therefore, x will now be equal to y to the power of 3. X will be equal to y to the power of 3. Concept number 6. Concept number 6 talks about a situation where your subject is having a power. Now, in a situation where my subject is having a power, to remove the power, what I would do is to do root. Remember, we said the inverse operation of power is root, and that of root is power. So here now, to remove this power of 3, I will have to do the corresponding root, which is cube root. So I will say cube root of z cube equal to cube root of y. Remember, you must do that to both sides so that your equation can remain balanced. Anything you do to one side of an equation, you must do the same to the opposite side. So cube root of z cube, the cube root will cancel the cube. So we're going to have z is equal to cube root of y. So z is our subject, now standing alone on the right. Concept number 7. Concept number 7 talks about a situation where your subject is appearing in 2 or more places. So here we have our subject. The intended subject here is x. The x appears here. The x also appears here. Therefore, to make x the subject here, because we have 2x, we have to bring the two of them together. We will treat both terms as like terms. We'll treat them as like terms. Therefore, bring the two x together. So yx here. Now bring positive xz here. That will become negative xz. Now take negative a here. That will become positive a. Now look at this term. Look at this term. They have x in common. So we can factor out the x. So if we factor out x from xy, we'll be left with y. If we factor out x from xz, we'll be left with z equal to a. Now look at our subject here, x, is multiplying this expression, y minus z. So what is the inverse operation of multiplication again? Very good, division. So we divide both sides by y minus z. So divide this by y minus z. Divide this by y minus z. Y minus z will cancel y minus z. Therefore, again, we will have x, our subject, equal to a all over y minus z. So these are the concepts that you will apply anytime you are confronted with a question on changing the subject of any formula. Now let's look at the following examples using the concept that we have just learned. Now for question number 1, we have v is equal to u plus 80. Presently v is the subject and we are asked to change the subject to t. So look at where my subject is. My subject t is here. My intended subject is here. Now look at this. This 80 is added to this. Therefore, what do? What's the opposite of addition? Subtraction. So I will minus u from both sides, or I can just take the positive u over to the left. That will give me negative u. So I'm going to have v minus u equals 80. We're not done yet. So look at my subject again is multiplying a, is multiplied to a. So what is the inverse operation of multiplication? Very good, division. So we divide away the a. So we divide both sides by a. So divide this 80 by a, v minus u by a. The a here will cancel this a. So the right hand side you'll be left with t on the right hand side. T equals to v minus u, and boom. That gives us our subject. Number 2. We have I is equal to PRT over 100. Remember, this is a situation where our subject is involved in a fraction. We said that earlier, whenever our subject is involved in a fraction such that we have a single fraction on the left and a single fraction on the right, I can make this over 1, turn this to fraction by putting over 1. So what do I do next? Cross multiply. That's the concept when your subject or your intended subject is involved in a fraction. So we cross multiply. 100 times I will give us 100i. 1 times PRT will still be PRT. Now 100i equals to PRT. Don't forget our intended subject here is letter T, and the letter T is multiplying P and R. So what is the inverse operation of multiplication? Division. So we divide both sides by PR. Divide both sides by PR. So if we divide both sides by PR, the PR here will cancel, the PR here cancels this, so we'll be left with T is equal to 100i over PR. Boom. That gives us our subject. Number 3, we have A is equal to 1 over 2BH. We have to make this H the subject. Again, this is a situation where our subject is involved in a fraction. So put this over 1 again and cross multiply like we did previously in example 2. So cross multiply. 2 times A will give you 2A. 1 times B times H is still BH. 1 times BH is still BH. So here we have BH is equal to 2A. Now we're trying to make H the subject. See, H is multiplying B. What's the inverse operation of multiplication? Again, division. So divide both sides by B. So the B here cancels the B here, and that will give us H is equal to 2A over B. To number 4 again, we have to make R the subject. Again, we have a situation where our intended subject is involved in a fraction. So cross multiply again. You will have 3v is equal to 1 times pi times r squared times h. That's the pi r squared h. Now look at this, our intended subject. The letter R is what we intend to make the subject, and the r squared is multiplying pi and h. Therefore, the first thing here will be, the next thing here rather, will be to divide both sides, divide away the pi and the h. So we divide both sides by pi and h. So pi cancels pi, h cancels h. So we'll be left with r squared is equal to 3v over pi h. 3v over pi h. Now look at R, we're not done yet. R is not yet a subject because it's having a power. So it's having a power of 2. What is the inverse operation of power? Very good, root. So roots, the corresponding root of power of 2 is square root. So we'll do square root of both sides. We'll do square root of r squared and square root of 3v over pi h. The square root now will cancel the square. So we'll be left with r equals to square root of 3v over pi h, square root of 3v over pi h. And to question number 5, we have 1 over f is equal to 1 over u plus 1 over v. We have to make v the subject. Look at where my subject is. My intended subject is here. So, and this 1 over v is added to 1 over u. So the first thing I can do is to subtract 1 over u from both sides. Subtract 1 over u from this, subtract 1 over u from this, or simply I can just take the positive 1 over u to the left hand side. That will become negative 1 over u. So we're going to have 1 over f minus 1 over u equals 1 over v. Now look at, this is a situation again where our subject is involved in a fraction, but here we cannot cross multiply here. We can't cross multiply here because there are 2 denominators on the left hand side. So if we attempt to cross multiply, we don't know if it's u that will go here or if it's f. So whenever you have your subject involved in fractions such that you have 2 or more fractions either on the left or on the right, you can't cross multiply. What you would do first is to turn all the fraction into a single fraction by doing LCM. Please take note of that. So here we have to find the LCM of f and u. LCM of f and u is fu. So now fu, if f divides fu, we'll be left with u. The u multiply this 1. So u times 1 will give you u. U times 1 will give you u. Now if u here divides fu, u divides fu, we'll be left with f. The f will multiply this 1. So again we'll be left with, we will have f. So I'm going to have u minus f all over fu equals to 1 over v. You can see now I now have a single fraction on my left and a single fraction on my right. So now I can cross multiply. So v will go here to multiply u minus f. Fu will go here to multiply 1 when you cross multiply. So fu times 1 is fu. Now don't forget our intended subject is this letter v. And look at the letter v now is multiplying this expression. Is multiplying u minus f. What is the inverse of multiplication? Division. Very good. So we divide both sides by u minus f. So divide this by u minus f, divide this by u minus f. So u minus f here will cancel this u minus f. So we'll be left with v is equal to fu all over u minus f. Boom. And that gives us the subject v. To question number 6, we have t is equal to 2 pi square root of L over G. We are to make L the subject. Now look at where my subject is. My subject is under a root. Is under a square root. And that square root now is now multiplying 2 pi. So the first thing I want to do here is to divide away these 2 pi. Divide away these 2 pi. So divide both sides by 2 pi. These over 2 pi, these over 2 pi. So 2 pi will cancel 2 pi. We'll be left the square root of L over G equals t over 2 pi. Now look at my subject again. It's still under a root. Remember, what's the inverse operation of square root? That's power of 2's. Very good. So we raise both sides to the power of 2 to eliminate the square root. We raise both sides to the power of 2. So t to the power of 2, that is t squared. 2 pi to the power of 2, that's 2 to the power of 2, that's 4. 2 raised to power 2 will give you 4. That means 2 times 2. Pi raised to power 2 will give you pi squared. So we're going to have t squared all over 4 pi squared equals to, the square here will cancel this square root. So this will be left with L over G. So we have L over G is equal to 2 squared over 4 pi squared. Now look at, don't forget our intended subject is letter L. And now the letter L is being divided by letter G. So what do? The inverse operation of division is multiplication. So multiply both sides by letter G. So this G will cancel this G. So we'll be left with L equals to GT squared over 4 pi squared. And boom, that gives us our subject. To number 7, we have A squared is equal to B squared minus C squared. We have to make C the subject. Now remember what I told you, whenever your subject is having a negative, preferably move that your subject to the opposite side. Alright, so here my subject, this is my intended subject, letter C, and I can see it's negative. So I will carry minus C squared, transfer the minus C squared to the left, it will become positive C squared. Then bring A squared, positive A squared to the right, that will become negative A squared. So we have C squared is equal to B squared minus A squared. Now look at your subject, C is carrying a power of 2. What is the inverse operation of power? Power of 2, that's square root of 2. So we do square root of both sides. Do square root, square root. The square root will cancel the square here. So you'll be left with C equals square root of B squared minus A squared. Now to question number 8, we have A is equal to 2 pi r squared plus 2 pi r h. We have to make h the subject. Now look at where the subject is. The subject is here. and the whole of this expression is added to this. What is the inverse operation of addition? Subtraction. So we minus this thing from both sides, or we can just say take this over to this side. So that will be a minus 2 pi r squared equals to 2 pi r h. Don't forget, h is our intended subject, and you can see the h is multiplying 2 pi r. What is the inverse operation of multiplication? Division. Very good. So we're going to divide away this 2 pi r. So divide both sides by 2 pi r, 2 pi r. The 2 pi r here will cancel the 2 pi r here. So you are going to have h is equal to, we're going to have h is equal to a minus 2 pi r squared all over 2 pi r. Now finally, to question number 9. This is an example of a situation where your subject, your intended subject, is appearing in two places or more. So we have 2xy equals to bx minus 5. We have to make x the subject. So this and this will be treated as like terms. So we'll have 2xy, bring the bx here, so you have 2xy minus bx is equal to negative 5. Now look at x. You have x in this term, x is also present in, so factor out the x from both terms. So if we factor out the x from this, we'll be left with 2y, excuse me, and if you factor out the x from this, you'll be left with b equals to negative 5. Now look at your subject. Your intended subject is multiplying, x is multiplying the whole of this expression. So to remove the x, what do? We divide both sides by 2y minus b. So divide this by 2y minus b, divide this by 2y minus b. This will cancel this. Therefore, x is equal to negative 5 all over 2y minus b. So x is equal to negative 5 over 2y minus b. Now, this expression can also be written as, it can further be written as minus 5 all over, I can swap these two terms. So swap negative b plus 2y. Now factor out negative from the denominator. So if I factorize minus, I'll have b minus 2y. Then the minus here will cancel this minus. Therefore, this is the same thing as 5 all over b minus 2y, as you have it here. So this is correct. This is also correct. So thank you for listening. Now I'd like you to try the following examples. For number 1, you have to make r the subject. When you are done, you should have cube root of 3v over 4 pi. For number 2, you have to make s the subject. When you are done, you have to have s is equal to v squared minus u squared over 2a. For number 3, you have to make z the subject, and your answer should be 5xy over 2y minus 4x. And lastly, for number 4, you have to make t the subject. Your answer should be 4 pi squared f squared m. Go ahead now and try this example, and let's see if you'll be able to arrive at the answers shown on the screen. Thank you for your time, and see you in the next video.